Good morning and welcome to today's mission status briefing. With us today is Kwatsi Alabarujo, the lead shuttle flight director, just coming off his Orbit 1 shift. Kwatsi?
Thank you. Well, good morning. The SES-135 mission continues to go in absolutely outstanding fashion. Our crew, as you're used to hearing now, is continuing to perform incredibly. We are running right about on the timeline with respect to transfer operations of cargo from the shuttle middeck and the MPLM, as well as the transfer return. The crew generally, of course, has been very efficient. However, we've experienced a couple of minor problems or little hiccups along the way, which we'll tell you about, that have used up a little bit of time, but because of their overall efficiency and their organization and how well the transfer has been going, it's not going to impact the mission to any significant degree. Right now, we're about 70% complete with all of the transfer that the crew was timelined to accomplish during this mission, and that's just 70% with respect to the number of items that they'll lay their hands on. That doesn't correlate necessarily to the amount of volume that's been transferred or the amount of mass. But we think that we'll be at about 70% of the total mass that we're going to transfer sometime tomorrow. In the afternoon today, the crew has got some off-duty time, which is very well deserved, just so they can not so much unwind, as it were, but just throttle back a bit because they've been working really hard. And of course, this off-duty time is prescribed by our shuttle crew scheduling constraints in order to maintain overall fitness and health of the crew as we proceed with the mission. Now, many of you have heard by now, last night in the middle of the crew's sleep, we had a problem with general purpose computer number 4, that's GPC number 4 on the shuttle. That GPC was configured as our systems management machine, or SM machine, as we like to say for short. You know how fond we are of our acronyms. But basically, the SM machine, what it does for us is some environmental control. It also controls the antennas for our communication system, as well as does some general fault detection and enunciation for the orbiter's core spacecraft systems. That computer returned an error code. It basically failed in a manner that we call a fail to quit, which essentially means that it just stopped. And so the master alarm that was enunciated when that happened, right around 2-ish hours into the crew's sleep, that woke the crew up, and they spent about 30 minutes reconfiguring the computers to move the systems management functions to general purpose computer number 2, GPC2. We then shut off GPC number 4 and replanned today's plan to do some detailed troubleshooting on it. We allowed the crew to sleep in about 30 minutes later, since we did take about 30 minutes away from their sleep, and they did take us up on that. And so once the crew got going with their day today, Commander Chris Ferguson and pilot Doug Hurley took about 45 minutes to run this troubleshooting procedure on GPC-4 to basically bring it up to do a data dump of the memory from GPC number 1, which was the active primary GNC computer that saw GPC-4 status when it failed. So we dumped that computer's memory. We then initialized GPC-4 and dumped its memory to see what it thought about why it failed. And then we did an initial program load. Essentially ran the exact same procedure that we ran a few days ago in response to the switch T's failure on GPC-3. GPC-4 actually did behave itself. It did recover. The dumps were completed nominally, and our engineering teams are analyzing that dump data right now. It'll take about another several hours to get the results of that dump data. We expect a full report from the engineering teams when my flight control team comes on shift tomorrow, or actually really later tonight. And right now, there's no smoking guns that they've identified as to the cause of the failure. In such a case, we treat it as really a transient hardware failure that might be stimulated by any number of things. Radiation is one possible cause, but we don't have any conclusive evidence of that, although the orbiter was flying through the South Atlantic anomaly at the time of the failure. So that's just one of the many things that we think about. So once we brought that computer up, we basically put it to sleep, just like we did with GPC-3. And so we're now in a nominal config again with GPC-1 as our GNC computer, and GPC-2, which is slightly different, as our systems management computer. And we're going to stay in this configuration probably for another couple of shifts, another several hours, and think about getting some runtime on GPC-4 before we undock, just to observe its performance and see if there's anything additional that we want to do with it. Now, once we review the results of the data dumps and the memory analysis that the engineering teams are doing, that still may reveal something that leads us to investigate some other possible root causes and to think about some other things that we might want to do with the computer. But for the time being, we've got it recovered, and we think it'll probably continue to function well for us for the duration of the mission. The other little anomaly that you might hear about shortly is a broken latch on a locker door where we store our lithium hydroxide canisters. These canisters are our CO2 scrubbers on the orbiter. We don't need them right now for the CO2 control on the shuttle, because the regenerative CO2 removal systems on the International Space Station are providing more than sufficient capability to control CO2. But we were scheduled to get into that LIO locker, if you will, to change out some of the canisters that are on the space station, older canisters with the fresh canisters that we flew up on Atlantis. That's the standard procedure that we typically do during these missions in order to make sure that the International Space Station has the freshest canisters that are possible. And so we will have to probably do some kind of maintenance activity on that locker to get it open at a convenient time. Might get to do that sometime today, maybe sometime tomorrow. But other than those things, again, Atlantis continues to perform beautifully. The transfer mission is going very well. We haven't experienced any other significant problems with the spacecraft, and of course we're going to continue to watch the computers and make sure that they behave themselves. But right now we think we are very much on a path where we will likely be able to configure the computers nominally for entry and landing on flight day 13. So that's the status that we've got right now. Tomorrow we have on the plate more transfer. Again, repetition of pretty much a same theme with very little variation. Cargo transfer, and more cargo transfer. But again, that's the reason that this spacecraft is docked, and that part of the mission is going very, very well. At this point, I'll turn it back to you.
Thank you, Quadzi. We'll take questions now, starting here at Johnson Space Center. Please remember to step to the mic to ask your question. And please remember to identify yourself by name and affiliation.
Thanks, John. All right, it's Mark Carreau for Aviation Week. And could you go over what the nominal configuration for the GPCs would be for landing? And also, it doesn't look like there's any common thread between 3 and 4 at this point. But just to be sure, do you consider 3 available for anything you need it to do?
Okay.
For the rest of the mission and landing.
Great questions. First off, let me answer the shorter question to answer, and that is about GPC-3. Right now, we consider GPC-3 a perfectly healthy and functional GPC that is available for use for whatever we might need to use it for. Typically, we will use it as a guidance, navigation, control computer, and we don't see any leans against doing that at this time. Now, the nominal configuration of the GPCs for entry, essentially, we will nominally have all 5 GPCs up. GPCs 1 through 4 run what we call our PASS software, basically our primary avionics system software, and they run redundant copies of that software so that they are all computing the same thing and talking to each other so that they can check each other out and make sure that all of the computers are functioning properly and computing the same result given the same inputs that they derive from their flight critical buses. GPC-5, which is also up and running for landing, performs the exact same functions except with a completely different flight software package that's made by a different vendor, and so this provides us some redundancy and protection against any insidious software issues that might conceivably take down all 4 past GPCs, given some anomalies or singularities in computation, divide by 0 errors or something insidious like that. And so normally all 5 of those computers are up. The way we configure the computers is we assign each computer to talk and to drive, if you will, one of the flight critical buses. A bus is just simply a collection of input-output devices that link the computer to physical pumps, valves, flight control surfaces, thrusters, jets, engines, and other things that are required to fly Atlantis. And so we have 4 flight critical strings, 4 flight critical buses, and we assign GPCs 1 through 4 to the buses 1 through 4 respectively. GPC 5 runs the backup flight software, and again provides some redundancy as far as the software part of the computer management. And all 5 of those computers will be up for entry, and ideally we won't have any additional problems or failures.
Philip Sloss with NASASpaceflight.com. A couple of questions. First, did you see any kind of a failure signature? Well, not your shift, but the Orbit 3 shift. Did they see any kind of a signature at the time of failure for GPC-4?
Are you asking if there was some kind of telemetry or leading indicator before the MDM failed or the GPC failed?
Yeah, or like was there any errors or anything like that were seen at the time, or did it just fail to quit?
There was nothing that was seen in telemetry for that computer at the time. It just failed to quit. Happened pretty much right out of the blue. The flight control team responded per procedure and reconfigured. Of course, our initial indication was the master alarm that we saw in telemetry that when the system failed, and several of our flight controllers, of course, reported indications that they would see as a result of losing the systems management function on that GPC.
And then the frequency of this type of a failure, is this something that has been seen before? And if so, how frequently has it been seen just in the recent past?
Well, this type of a failure is actually very infrequent. This is the really only the second bona fide in-flight anomaly that we have had of this particular design of GPC. We've had 2 designs of GPC in the shuttle program. You may have heard last time we talked about computers, Mr. Harwood, I think, mentioned that we had a number of computer failures on STS-9. That design or model of general purpose computer was phased out some years ago. And so the current model of GPC that's in use has only experienced one other anomaly like this, and that was on STS-71 back in the summer of 1995. And interestingly enough, it was also on Atlantis and also on GPC-4. Now, that's the slot that the GPC was in when it failed. The actual physical serial number in hardware is not the same. It's not physically the same computer that was on Atlantis back on STS-71. But basically, that's the only other failure we've had from this series of computer in orbit.
Additional questions? Robert?
Hi, Robert Perlman with CollectSpace.com. On the stuck latch on the locker, you mentioned maintenance. Can you qualify that a little bit? Is it pulling out a pry bar and trying to get yourself into that mechanically, or is it unscrewing the door, or how is that done?
Okay, great question. The particular locker in question has an access door on it. However, the entire panel on which that door is situated and attached is fastened to the floor with about 25 captive fasteners. And so essentially we just essentially have to go to the edges of that whole panel after we remove the cargo and various other things that are stowed there from the area, and just unhinge and loosen those fasteners, and then we can remove the whole panel and get to the back side of that door with the stuck latch, and then we should be able to remediate it fairly quickly by resetting a set screw, which we think has probably come loose, or maybe trying to address a failed spring of some kind.
Denise?
Denise Chow at Space.com. With the GPC-3, how confident are you that you won't have another switch tease or related incident during reentry?
Okay, great question. Well, we're going to basically see where we are with that GPC when we bring it up for undock and fly around in a few days. Now, one of the things about the switch tease phenomenon is it's really a feature of the switch. It's something that we cover in training, and you know, when I went through my initial data processing system training a few years ago, and I first tried to expand a set and power up GPCs, I did the exact same thing. It's something that can sort of happen if you're not really paying attention. It's the technique for avoiding a switch tease is actually very easy to implement. So we are pretty confident we won't have the problem again. If we do, however, we do know how to bring that computer back up. We'll be on the lookout and ready to implement the procedures that are required to reinitialize the computer within a reasonable amount of time. And so we should have plenty of time to get the computers in proper configuration prior to execution of the deorbit burn for entry.
Irene?
Irene Klotz with Reuters. 2 computer glitches on one flight seems pretty high odds. How do you know they're not related?
Well, for the GPC-3 case, when that MDM, or excuse me, MDM is what we call them on the space station side, when that computer failed, it failed at the moment the crew was actuating the switch. We got feedback from the crew about what had happened. The signature was consistent with the ops notes that we have consistent with the switch tease. In this case, the crew was asleep. Nobody was anywhere near the switches, and so this signature and the circumstance was different. Now, to be sure, as I said earlier, until we complete our analysis of the dump data, we have no idea exactly what caused the failure of GPC-4. The fact that GPC-4 was able to be reinitialized is very telling, because what it says is that whatever the issue was, it's either software or a transient hardware issue. And of course, transient hardware issues tend to fall in a fairly limited subset of things that you'd look for, things like radiation or some kind of electrical anomaly that we can go investigate. So we've got different circumstances, different signatures. The fail condition on GPC-3 was different. GPC-3 actually failed to halt, whereas this computer failed to quit, which is 2 different computational and physical states of the hardware. So until you complete your analysis, you can't really say anything for sure, but we've got many reasons to believe that these 2 failures are not caused by the same thing. Now, the fact that we did have 2 computer failures on the same flight on a spacecraft that's otherwise performing beautifully, that's not at all lost on me. I do have a saying that you're not paranoid if they really are after you. So I am cautiously optimistic that we'll have a healthy data processing system for undocking for the rest of the mission and for re-entry, but we will be watching closely.
Any other questions here in Houston? Ted?
Ted over Channel 13 here in town. During the crew briefing, we heard one of the station members say, you know, this thing's starting to look smaller. Can you explain where they're putting all this stuff, and you know, why would the station seem smaller in his estimation?
Okay, that's an excellent question. The station is starting to seem smaller because we have brought up in the MPLM and in the mid-deck an incredible amount of stuff. And of course, that's a technical term. There's just so much cargo and so many large bags that have been brought up. Now, as they're being unloaded from the MPLM, they are being stowed in the livable spaces on board the International Space Station. They're being stowed in the lab module, in Node 1, Node 2, in the GEM, wherever we can reasonably put them, in the PMM, the Pressurized Multipurpose Module. And so as all of this cargo is being deployed, in addition to the supplies, the provisions, and spare parts and other cargo that was already on the space station, there are certain portions of the space station, certain modules, certain habitable volumes, which quite honestly get cramped. That is a price that we are paying for bringing up these supplies. But as the orbiter leaves and the crew resident on the space station is able to leverage and manage that cargo to be placed more efficiently and to be placed according to their priority of need for ongoing undocked operations, things will level out more as the visiting vehicles that are coming up over the next several months come up and we dispose of foam in those visiting vehicles as trash. That's going to help a lot. One of the things you have to understand is that with the cargo that we've brought up, in order to make sure that it survives intact its ride on the space shuttle, it's packed in a great deal of foam. In fact, much of the volume that is taken up by this cargo is its packing foam designed to protect it. And so once it's on orbit and once the foam is no longer needed, that really represents a bit of a nuisance more than anything. And so we'll try to pack as much of that foam as possible in the MPLM for return. So hopefully the spacecraft will seem a bit less cramped in a few days when we get ready to close out the MPLM. And then of course there's just a natural situation where there's other pieces of foam and other packing material that we just won't be able to dispose of until much later, say on a Progress vehicle or one of the other visiting vehicles that come.
Okay, anybody else here at JSC? We'll take questions now from Kennedy Space Center.
Hi, Marcia Dunn, Associated Press, with a couple questions. For GPC-3, you described it as failed to halt, I believe. I'm not quite sure exactly what that means. Is that also an immediate shutdown? And how many times have you seen that type of occurrence on orbit before?
Okay, in the event of a fail to halt, and basically what that's saying is, we have a mode switch that tells the GPC, if we switch it to that position, tells the GPC to halt, which essentially means to stop computing. It doesn't flush it or purge it of its software. It doesn't register necessarily any errors in the box itself, but it just stops. I like to think of it in layman's terms as analogous to when you simply close the lid on your laptop. Your laptop is really asleep. The operating system is still active in some small part of the computer's memory. If you open the lid on your laptop, you'll essentially be able to resume your session exactly where you left off. That's the way you should think about the halt state. In the case of fail to quit, the application software that's in the computer as well as the operating system, it just stopped. Computation stopped. All of the processes just simply stopped in an otherwise unrecoverable manner. And of course, we, by necessity, did have to do a data dump and reinitialize that computer. Now, as I indicated before, the only other instance of a spontaneous on-orbit anomaly that we've seen, like what we had on GPC-4, was on STS-71. As far as the issue we had with GPC-3, the sort of the switch tease phenomenon, I don't have exact numbers, but I know we've seen that in orbit a few times. As I said, it's a feature of the switch, and if you don't finesse it quite the right way, you're prone to get that situation.
Thank you. And I'm wondering what happens if one of the other three GBC also experienced some sort of quit to halt, quit to quit. What happens then? And is there anything that you could think of that might come back from this analysis that would prompt you to consider an early return?
Well, according to our flight rules, we would have mission duration impacts if I lost if I lost two computers essentially. Then we would attenuate the mission into what we call an MDF, or minimum duration flight. If I lost three computers, then according to my rules, I would be looking at coming home essentially at my next primary landing site, which would be essentially within the day. So as long as I have a computer that I have demonstrated I can load and bring up into our redundant set and into our common set, if you will, and that's the collective of redundant computers, if you will. As long as I've demonstrated that I can do that, I don't have any acute mission duration impacts. Now, having said that, If we were to experience another problem with a different computer, honestly, I think we would all be thinking very, very hard about what was going on. We do what we always do, which is we would get the data first. The very first steps of our troubleshooting procedures are to do data dumps. We do data dumps of the computer that was functional and monitoring the other computers in the set to see what it saw. We do data dumps of the failed computer to see what it thinks it saw about itself. And we get the engineers to analyze that and take a good hard look at it. Beyond that, we draw some reasonable conclusions about what would happen. So that's about as much as I could tell you about our response to another issue. Again, just to emphasize, even with the problem we had on GPC-3, which was due to a condition that we have an explanation for, and the problem that we've had on GPC-4, which we don't yet have an explanation for, what I can tell you is that we have demonstrated the ability to bring both of those computers up to full computational readiness and add them to our redundant set. And so that's a meaningful capability that we have.
I believe that was our last question from Kennedy Space Center. We'll go now to the phone bridge. We'll start with Bill Harwood.
Hey, thanks, Quatsi. I just want to follow Marcia's question. I have two quick ones along those lines. From a flight rules perspective, if you have a computer that's deemed the victim of a transient, I know that's addressed specifically in there. What does it take to make you fully trust it again?
Okay, that's an excellent question. A computer that is deemed to be the victim of a transient hardware failure, and how we get to that determination is after analyzing all of this dump data, after analyzing the memory of the computers, in the absence of any other credible explanation like a switch tease or some other issue, if we don't see any software problem or indication of a computational error, what that tells us, and the conclusion that we draw from that, is that there's some transient hardware-based condition that resulted in the GPC's temporary loss of function. In that instance, we have specific guidance as to which buses we will allow that GPC to drive. So in the instance of GPC-4, if it is determined that this was a transient hardware failure, my rules tell me that however I configure it, I can only assign it to drive what we call string 4. And that is chosen because of the types of hardware that are connected to that particular data bus. The hardware that's connected to data buses 1, 2, and 3 are deemed of such a critical nature that we don't want to subject them to the possibility of another transient hardware fault that might impact our ability to control the spacecraft during critical operations like undocking, fly around, and certainly for re-entry. So even the good news is that because this is GPC-4 and our nominal configuration for entry is such that we assign GPC-4 to string 4, even if it's deemed the victim of a transient hardware failure. Unless we see something more insidious that gives us pause, we can basically assign this GPC to its nominal string, to its nominal data bus that we would normally do for entry, because if it does experience a problem during entry, the particular failure mode in this instance with that data config will not cause any immediate problems for controllability of the spacecraft during reentry.
Thanks, got that. And two more real quick ones. From the flight rule perspective and where you stand today, none of these computers are failed at this point. You have all 5 at this point, although there are some leans against 4 until you finish your analysis. Is that right?
That's absolutely correct.
Okay, thanks. And, you know, reporters, whenever things like this happen, we all focus on this and think about it real hard because we don't understand it to the degree you do. Do you consider this a major issue, a minor issue, or something in between?
Well, I tell you, I consider every issue a major issue until I believe we fully understand it and have no reason to think otherwise. So right now, again, we've analyzed only part of the dump data bill, and we haven't seen any obvious software problems. Honestly, that's the thing I tend to worry about the most. You know, there's some error in the flight software that we haven't caught, and because of the exact time of day and the time of the year and the particular value from the master clock when figured into all of the other computations basically makes the thing fail. That sort of thing, that's the scenario that tends to keep me up at night. So once we complete the dump, complete our analysis, of the dump data and determine that we don't see any indications of that type of scenario, then I will be a bit more comfortable. But I never let myself get too comfortable until we've got all of our friends with their boots on the ground.
Okay, well, thanks. Well, let me just squeeze in one last quick one, though. At this point, barring something unusual, like you say, with the software or whatever, you would expect to have all 5 of these guys up and running for entry.
At this point, that's my expectation, but again, that's pending the results of the remaining analysis of the dump data.
Okay, thanks a lot.
Okay, thank you, Bill. James Dean?
Thank you very much, James Dean with Florida Today, and I guess just one more on the GPCs. I'd start with, so I understand the expectation is you'll have all 5, but setting aside more critical issues, I guess, where you'd have to cut short mission duration if you didn't have all 5. Again, I'm just trying to understand how that would impact the orbiter's ability to execute its undock and reentry and all that stuff. I mean, do you really actually only need as few as 1 computer to get through it all, or what is the impact of not having 5 if that were to turn out to be the case?
Okay, let me try to address your question without boring you. Basically, the benefit we have from the multiple computers during the critical phase is that we can have more than 1 computer assigned to drive a particular data bus or a particular set of equipment on the spacecraft that we need to control thrusters, to steer the spacecraft, and to get critical navigational data from its sensors. And so by having multiple computers, we are able to selectively assign each physical machine to drive a particular data bus, while, again, in the redundant set, those computers talk to each other so that they can monitor each other's performance and exchange data and fundamentally compute the same things. And so what that does for us is it prevents the failure of any one computer from taking away functionality that might cause a dangerous loss of control of the spacecraft. So I just set that up because that's fundamentally the driver that really drives how we manage these. So if we do have a problem with another computer, or we see something something with GPC-4, for instance, in our analysis, such that we will not have it up for entry, again, we don't think that's where we'll get to, but if we do get there, what that simply means is that the data bus that would normally be driven directly by GPC-4 will simply be assigned to another computer, and that other computer, which would normally only have 1 bus assigned to it for entry, would have 2. And the way we would pick which computer would share the 2 buses is based on what provides us the best failure tolerance against a loss of control or degraded control for that situation. So hopefully that makes some sense.
Okay, thank you. And wondering if you mentioned the transfer completion percentage, and wondering if these glitches and other special events we're seeing today have I guess the crew already had some off-duty time built in, but would you still say they're ahead of schedule, or will be by the end of the day, or has this slowed them down a little bit more and maybe put them just on schedule? And as just a quick follow-up to that, since you've said that, I think the goal is to get Raffaello filled up to about 90%. Any possibility you have an estimate of the actual pounds of cargo that amounts to being loaded back into Raffaello?
Okay. To address the first question, these problems, these little glitches, if you will, have indeed slowed the crew down. Now, the good news is because they were running ahead of the timeline, not tremendously ahead with the transfer, because the transfer is really the meat of the mission, and it's It's a really messy operation until you get everything organized. But Sandy and the rest of the crew were running far enough ahead that once we took some time to troubleshoot the computers, to give the crew an extra 30 minutes of sleep time this morning to make up for the sleep time that was lost, all of those little things, we are right on plan at this point. We're right on the timeline. So the little margin we had, we gave some up for computer troubleshooting, and now we're right on plan. As far as an estimate of the amount of mass, honestly, right now I can't really give you a great estimate. We're at a phase of the choreography of transfer to where I really won't know what the mass properties of Raffaello look like until we complete the evening transfer brief tonight and have incorporated all of the updates we get from Sandy into our transfer plan for tomorrow. I think probably this time tomorrow, Chris Edelin or the other flight directors on the station side will probably have a better idea of how much mass is in the MPLM.
If I could ask just one more question on transfer, is that the essentially what you've gotten out of the extra day that's been added is just increasing that percentage that you're loading back into Raffaello? Is that essentially what's been gained aside from any other sort of organization of stuff on the station?
Increasing the percentage of cargo that we load into the MPLM, that's a big piece of what's been gained with the extra day. We think we are on a trajectory to where we will be able to fill the MPLM up to virtually 100% volumetrically. And so that's a big piece of what's been gained. The other part of what's been gained is that we have additional time to do some science that we weren't otherwise planning to be able to do, and to get the samples, many of them are biological, from that science back home on the orbiter on a much accelerated time frame than we were otherwise expecting to.
Thanks very much.
Okay, thank you, James. Do we have anyone else on the phone bridge, please?
Yes, Charles Atkinson.
Yes, go ahead.
Yes, Charles Atkinson, Examiner.com, SpaceLaunchNews.com. Turning over to the weather, I was wondering if you could comment if you've been in talks with JAXA on the pending Typhoon Mahan that's approaching southern Japan, possibly Tuesday night.
Okay, unfortunately I don't have any information on that at this time, but we'll be sure to get some information and provide some feedback for you on the mission status briefing tomorrow or the following day.
Okay, thank you so much.
Okay, do we have any follow-ups here at Houston? Mark, I'm sorry.
Thanks again, Mark Carreau for Aviation Week. If you look at what happened with GPC-4, and it looks like it had something to do with flying through the South Atlantic anomaly and radiation, where does that leave you with GPC-4 in terms of future ops? Can you use it for re-entry and undocking and all of that? Does it leave you with a hardware question that kind of puts you back in a quandary?
Okay. If it turns out that we have no other credible explanation or smoking gun, if you will, and just to be clear, after we analyze the dump data, if we don't see any obvious problems or any indications of software or computational errors, the global category of what's left, which is the transient hardware failure, could be anything. Radiation being one of many possible causes of a transient hardware failure. In that case, we would treat the GPC as suspect, if you will, just to use layman's terms, and as I described the flight rules earlier, there are certain flight critical buses we simply would not assign that computer to control during critical operations like the undock and fly around. And so what I would do as my team will be executing the undock and fly around is we would assign the associated flight critical buses to the other computers that we had available to us. Now, since GPC-5 has our backup flight software, and we normally keep that asleep to serve as our BFS or backup flight software machine, I would continue to leverage GPC-2 notionally to do our systems management functions and rely on GPCs 1 and 3 for the GNC function during the undock and fly around. Now, for entry, again, because of how we normally do the stringing and which data bus I'm allowed to put GPC4 on, I would actually have something that very much looks like a nominal stringing for entry. So between undocking and entry, we would probably have GPC4 remain asleep, except for periods where we might want to get some innocuous runtime on the GPC just to watch it compute without it driving any flight critical buses. But it'd probably stay asleep until it was time to bring it up and string it for entry.
Irene Klotz with Reuters. Just to make sure I understand, the bottom line with all of this is that if GPC4 is transient, it is not considered failed for the flight rule that would come into play with a 2 out. And then this other question, and it's really silly, but at this point, with the way the computers are right now, has there been any changes at all to how you want the crew to be packing stuff up for the return home or unpacking things? Has there been any kind of mission logistics impacts, just 5 failure modes down the way if you did end up having to leave early? Thanks.
Okay, that's an excellent question, and the easy answer is we have not changed any aspect of how we've been executing the mission as a result of the GPC failures. From a strategic perspective or from a tactical perspective with respect to the transfer, we are executing on plan. The only adjustment we've made is because we took about 30 minutes of the crew's sleep time last night to move the systems management machine to GPC-2. We gave them an additional 30 minutes to sleep and adjusted our plan to make everything fit in the box properly. Other than that, there's nothing that we've done differently and nothing that we anticipate doing differently unless, again, we see something that's more sinister. And so far, we haven't seen any evidence of that.
Any others here in Houston? Seeing none, a couple of NASA television programming notes. At 11:29 Central Time, 12:29 Eastern, President Barack Obama is scheduled to call station crew members. And at 1:30 p.m. Central Time, 2:30 p.m. Eastern, we'll have a replay of the crew news conference. An additional reminder, you can follow activities of the International Space Station and the Space Shuttle at www.nasa.gov. Thank you, Kwatsi, and thank you all for coming.